Hi, welcome to this lesson on sequences and series. In this lesson we're going to take an introductory look at the difference between a sequence and a series with these three examples. So a sequence is any set of numbers that follows a particular pattern, and sometimes sequences might be arithmetic, which means that you're going to be adding or subtracting a particular value each time, and sometimes sequences might be geometric, which means you'll be multiplying by a particular value to get from one term in the sequence to the next. So if we look at these first couple examples, in the first one, we start with 5 as our first term. We go from 5 to 8 to 11 to 14. So first of all, let's see if we can identify what type of sequence we'd be looking at here. If you notice, we're adding 3 each time, and when you're adding by the same amount to each term in your sequence, that means that you're looking at an arithmetic sequence. So what would our next two terms be? Well, from 14, we're going to continue adding 3 each time, so this next term here will be 17. And then from there, we're going to add 3 again, and so that next term will be 20. So as we go through our sequence, we're going to continue adding the same amount every time in this arithmetic sequence. Let's take a look at a second example. In this one, we see that we go from 2 to 4 to 8 to 16. So if you were to look at the difference between each term, we notice that from 8 to 16, that's a difference of 8. Whereas from 4 to 8, that's only a difference of 4. So it's definitely not, in this case, an arithmetic sequence because we're not adding the same amount every time. So let's see what we are doing to get from one term to the next. If you said multiplying, correct. And even more specifically, what are we multiplying by to get from one term to the next? If you said we're multiplying by 2, then you're correct on that as well. And so here, we're doubling each term to get to the next. So this next unknown term that we have after 16, if we were to multiply 16 times 2, that would give us 32. And if we were to multiply 32 times 2, that would give us 64. Now some sequences, what we'll see in this final example that we have here at the bottom of the board, some sequences are going to be a little bit more complex. And in future lessons, we'll get to some of the more complex examples and how to address those. But something like this, if you look from 3 to 14 to 58 to 234, there's not a standard amount that we're adding each time, and there's not a standard amount that we're multiplying by each time. This is a more complex example, but still a sequence nonetheless. And to go ahead and give the answer away on this one, what we're actually doing for each term in this sequence, let me just label our second one, which is geometric, just so we know how to identify arithmetic and geometric. And for this next complex sequence, we're taking each term, we're first multiplying it times 4, and then adding 2. So this formula for this sequence would be 4x plus 2. And if you look at each term, if you were to multiply 3 times 4, that gives you 12, and if you add 2, that gives you 14. From 14 to 58, if you multiply 14 times 4, that's 56, plus 2 is 58. And 58 times 4 would give us 232, plus 2 gives us 234. So we can see that this formula holds true to take us from each term to the next in this complex sequence that we have at the bottom. Now next up, to learn what it means for something to be a series, there's just one simple difference in definition between a sequence and a series. A sequence is just a set of numbers that follows a particular pattern. A series, on the other hand, is the sum of all of the numbers in that sequence. So for example here, if we wanted to sum together each of these terms in our first arithmetic sequence, then for this series, we would have 5 plus 8, which is 13, plus 11, which would give us 24, plus 14, which gives us 38, plus 17 gives us 55, and plus 20 would give us 75. So if we're looking at this as a series, think of series as a sum. It's the sum of all the terms. So this series would give us a result of 75. Let's take a look at our next example. 2 plus 4 would give us 6, plus 8 gives us 14, plus 16 gives us 30, plus 32 gives us 62, plus 64 is going to give us 126 for this series that we have here. And our last example for the complex sequence that we have at the bottom, 3 plus 4 would give us 17, plus 58. Can we do that in our heads? If you got 75, that's correct. And then 75 plus 234, if we do that in our head, that gives us 309. So 309 would be the sum of that series that we see on the bottom of the page. So this is just an introductory look at sequences and series. To cover more topics, please feel free to leave feedback and let us know what additional topics in the sequences and series content you'd like us to cover. Otherwise, you can also visit our website at www.sandersontestprep.com. The link is in the description below. Thanks.